to work with vector ratio problems in 111 seconds. Let's go. This, guys, is definitely one of the hardest topics in the course, but don't worry, I'm going to do my best to make it clear. Let's have a look. The question says that the ratio of b to m to m to c is 1 to 3, and it asks us to express the vector b to m in terms of a and b. What are we going to do? Well, our first step is going to be to use the fact that the ratio of b to m to c is 1 to 3 to look at what fraction of our total side length b to c is represented by b to m and what fraction is represented by m to c. Now, this ratio here has 4 parts in total. We got that by doing our 1 plus our 3. One of those parts is our b to m, and 3 of them are our m to c. And what that basically tells us, guys, is going to be that our length b to m is going to be 1/4 of the total side length. That's going to be 1 part out of 4 parts in total, and the length m to c is going to be 3/4 of our total side length. We got that by doing our 3 out of our 4 total parts. Now what we can do is basically use the fact that b to m is going to be 1/4 of the length of b to c, and we can find our vector b to c and then find 1/4 of it, and that is going to give us our vector of b to m, which is what we want. So what we're going to write down here, guys, is going to be that our vector b to m is going to be 1/4 of our vector b to c. Then we're going to find our vector b to c, and how are we going to do that? Well, we know to get from b to c, we can go firstly from b to a, that's going to be the vector b, and then we can go from a to c, and that is going to be the vector minus a, because we're going in the opposite direction to this vector a. So we can write this as then 1/4 of b minus a. Finally, guys, if we want to, we can expand this to write it in its simplest form. What are we going to have? We're going to have that our vector b to m is going to be equal to 1/4 b minus 1/4 a. And that, guys, is going to be our final answer for our vector b to m. Hopefully that was clear enough.